Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the authentication module titled Username Enumeration via Account Lock. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on authentication labs, and select lab number 7, titled Username Enumeration via Account Lock. Alright, let's get started. This lab is vulnerable to username enumeration. It uses account locking, but this contains a logic flaw. To solve the lab, enumerate a valid username, brute force this user's password, then access their account page, and you've got candidate usernames and candidate passwords. Okay, so the target goal of the lab is to exploit the logic flaw to enumerate the list of valid usernames first, and then enumerate the passwords for the list of valid usernames. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version of Burp because we do need to use Intruder to automate a portion of this attack, and Intruder is heavily throttled in the Community Edition. Okay, let's click on My Account. And what we're gonna do is, let's say the first username is Carlos, and the password, let's say, is test. Hit login. So this is probably an invalid username and password. Let's send this to repeater. Hit send. Click on render. You've got invalid username and password. Render again. So that's number 2, number 3, number 4, number 5, number 6, number 7, and we don't get any lockout mechanism. So I'm wondering if that's because this is an invalid username that we don't get a lockout mechanism, and if we do try to brute force a valid username, we get that you tried too many attempts and so your account has been locked out. So let's test that out. Let's send this to Intruder. In Intruder, let's clear, and then under username, let's highlight that. And then for password, let's remove the entire thing and just add this twice. What that means is that we're trying to brute force usernames with empty passwords. And then in payloads over here, we're going to go back over here and get the list of candidate usernames. Let's copy this, paste it in here. So that's for the list of usernames. Now for the password over here, what we're going to do is we're going to click on payloads, and we need Pitchfork for this case. And for the second one right over here, we're going to click on null payloads, and we're going to say generate 5 payloads over here. So essentially what this will do is it'll try every username in the list 5 times to see if we get an account lockout. And the idea over here is we're trying to see if one of these usernames is valid, are we actually going to get an account lockout, or are we not going to get locked out just like for any invalid username? So let's click on Start Attack. And we're getting status codes of 400, so I'm definitely doing something wrong. And actually, I know what I'm doing wrong. So I selected the wrong type. So instead of Pitchfork, what we're looking at is Cluster Bomb. So the definition of Cluster Bomb is this attack uses multiple payload sets. There is a different payload set for each defined position. So because we need 5 null values of each username, we actually have to use Cluster Bomb instead of Pitchfork. So let's go to payloads over here. This is still correct. And for 1, we still have our usernames. So this looks good. And we go to resource pool. We do not need a custom resource pool. 10 is fine. So let's start attack. And it's going to perform 505 requests. So we'll wait for all of that to work, and then we'll see if one of our requests is giving us a different status code or a different length. Okay, so I'm getting 400 status codes for all of them, so that's not a good sign. Over here, it's telling me it's missing the parameter, and I thought I had resolved that issue. So let's close this, discard it, go back over here, payloads, positions. Okay, so I know what the issue is over here. It can't actually be null. You have to have something in there, and then this will allow us to do it for 5 times. So a null value that will be concatenated with this value over here. So I believe this should work, and we're getting 200. Okay, so this is good. Let's wait for it to perform all 505 requests, and then we'll see if it outputs a different length or a different status code that could potentially help us out when it comes to the username enumeration. Okay, so the status code is unlikely to change. Let's look at the length over here. So you could see acid has different length than the rest of them. So let's look at the response and render. And here we go. It says you've made too many incorrect login attempts. So if you try an incorrect username or an invalid username, you won't get locked out. But if you try a valid username, you will get locked out. And so the valid username over here is acid. So now all we have to do is brute force the password. So let's close this over here. Discard. Let's clear this over here. And then the username is acid. The password over here is what we need to test. And in this case, it's not cluster bomb, it's just sniper. Let's go back to the lab and click on candidate passwords. Copy it over here. Go to payloads, clear, and paste our list of passwords and click on start attack. Now, of course, if there is a lockout mechanism over here, we can't brute force the password, but I'm hoping there's no lockout mechanism and we do get a change in status code that could potentially allow us to figure out what the password is, and it does not look like it. So let's see over here the response and render it. And it's telling me you've made too many incorrect login attempts. So the request over here, you've got acid, and the response over here. Now notice some of the responses have different lengths. So we've got 124 is different from majority of the rest. So we've got over here invalid username or password. Over here we've got invalid username or password. And then over here invalid username or password. And then over here it says you've made too many incorrect attempts. Let's do a sort on length. And over here, again, we've got a different length. So this is really weird. Something is really wrong in the back end. Over here, we don't even get an error at all. So this is really weird. This tells me I should try this password and see what happens. So let's go back to our application, try the username that we found, so acid, and then the password Superman, and hit login and see if we could log in. And here we go. It allowed us to log in. So my guess over here is when an account is locked out and you actually try a correct password, what happens, the logic error in the backend doesn't output an error message saying that it's an invalid username or password like it does over here. It just redirects you to the login page because you're locked out. However, this way you have the ability to brute force the password, and all you have to do is just wait for the 1 minute soft lockout to complete and then try the password, which is what we did over here. So that's a really interesting logic vulnerability in the authentication mechanism of the application. Anyway, so we've successfully completed the exercise by exploiting the vulnerability using burp intruder. Now we usually script in Python. However, as you can see, there's a huge human element component to this lab that requires analysis, and so we can't script this in Python. In the next lab, we'll look at another case of a broken authentication vulnerability.